All right, welcome back to another video. And in this video, we're going to go over section 1.6 of college algebra. And it's basically going to cover what they call it, solving equations with radicals and absolute value. All right, so let's go ahead and begin. So we have the square root of 5 minus 4x, and everything is equal to x. Okay, so we want to get rid of the radical, and in order to get rid of the radical, we basically have to raise both sides to the second power. So is it safe to do so? Yeah, if we do it here on the left hand side, everything is just going to come out, right? And nothing is going to happen over here. Nothing bad. Nothing really bad happens from squaring, unless you're squaring some crazy binomial, which we may or may not see. We're going to find out. Anyway, let's go ahead and square both sides and see what we get. So over here we have the square root of 5 minus 4x. This whole thing is being squared equals x squared. So whenever you square something that's being square rooted that has a radical, it just comes out. We have 5 minus 4x. And this is equal to x risen to the second power. It's just x risen to the second power. So now everything is nice and clean, right? It looks like we're safe to start bringing things over to the right-hand side because, you know, we want to have the x squared term, we want to have numbers brought to that side. You don't want to move the x squared over. You could, but it's going to change it into a negative, and you really want to keep it a positive, just to be consistent. Okay, so let's go ahead and start by adding 4x to both sides. So that's gone. And let's go ahead and subtract 5 from both sides. So you're going to get 0 is equal to x squared plus 4x minus 5. And now this is factorable. So we have 0. And remember, it doesn't matter if the 0 is on the left or the right. Let's go ahead and factor it up. We have x and x. The c term is negative, so automatically this is plus or minus. Factors of 5 that when you subtract them will give you a 4. The only factor of 5 is 5 times 1. And yeah, that will give you a 4. Remember, the bigger number takes the sign. So 5 has to be the same sign as this term here, which will give you a positive 5. So make sure your bigger number between your two factors, make sure the bigger number always agrees with the sign in the middle every time. You can't go wrong, which means the 1 goes here. So now we're almost done. You get x is equal to, remember, set equal to 0 and move them over. X is equal to negative 5 and x is equal to positive 1. It's just the opposite of these. Now, because we were dealing with the square root, we have to make sure that it doesn't conflict with our original in any way. So you have to go ahead and plug in these, they call these proposed solutions, because there's a chance that only one of them is right. There's a chance that neither of them are right. So let's go ahead and plug them in. So very quickly, we're going to plug in the negative 5. So we have 5 minus 4 times negative 5 equals negative 5. So red flag right there. We have a square root. We have a radical on the left is equal to a negative. No way that's going to happen. So sadly, we're not going to be able to use the negative 5. Sadly, if you were to keep going, you know, you're going to get 5 minus 4 times negative 5. Remember to do multiplication first. So negative 4 times negative 5 will give you a positive 20. We have 5 plus 20, which is 25. And then you can do it this way. You can keep going. Is the square root of 25 equal to negative 5? No, it is not. So 5 will not be one of your, negative 5 would not be one of your answers. And we're going to do the same thing with the 1. So let's go ahead and plug in 1. Let's go up here to plug in the 1. We can use more room. All right, so we have the square root of 5 minus 1 times the 4 equals 1. So 4 times 1 is 4. 5 minus 4 is 1. We have the square root of 1 equals 1. Is that true? Yes, it is. So only 1 will be your answer this time. So that is our solution. Let's go ahead and plug in a 1. Fantastic. And yep, we have another square root property. Looks like this answer was 10. Let's hit similar exercise so you guys can see everything. All right. Let me clear that. All right, let's do it. So we have the square root of 3x plus 6 is equal to x minus 4. Let's start off by squaring both sides. So when you square this guy and you square this whole thing, you notice that I didn't do them individually, right? I didn't say, oh, that's x squared minus 4 squared. No, whenever you have a binomial like that, which, you know, a binomial is a fancy way of saying you have two terms. Whenever you have two terms and you're raising it to a power, you do the whole thing as a collective. You take the whole of x minus 4 quantities squared. Don't square them individually. You never square it individually. All right, anyway, on the left side, it comes out 3x plus 6 equals, and now over here, don't you have two of them? Just side by side like that. You have x minus 4 times itself. Isn't that what this is? Yes, it is. So now we can go ahead and distribute. So x times x is x squared. You have x times negative 4, which is negative 4x. You're going to do it again. You get negative 4 times x, which is negative 4x again. Then you have negative 4 times negative 4, which is positive 16. Let's go ahead and combine like terms. You get negative 8x plus 16 over here. We have 3x plus 6. And now we're going to bring everything over to the right-hand side. So over here is 0. You get x squared minus nothing else, right? Over here, you're going to subtract 3x from both sides. You get negative 11x. And then over here, you're going to minus the 6, minus the 6. So all that is gone. That's how you get the 0. And we get positive 10. Now, it looks nice and neat. Let's go ahead and factor up everything. So you get 0 is equal to, you know, we put x and x. And we have a plus. Our C term is actually a positive this time, right? So whenever you have a positive C, that means the signs in here have to be the same. Last time we had a negative C, that means the signs were automatically different, a plus and minus. Now, when your C term is positive, the signs have to be the same, but it's like, okay, they're the same, but are they both positive or are they both two negatives, like two minus signs? The answer to that is your B term. So the C term tells us whether or not it's the same. So we know it's the same, and they're both going to be whatever your middle term is. That's the trick. Okay, now factors of 10. We need to find factors of 10 that when you add them together will give you the middle. Notice that this is a plus, so you're going to add your factors as you find them. First factor of 10 is 10 times 1. Will 10 times 1 give you 11 when you add them? Yeah, so there's no need to find the other factors. We already have what we're looking for, 10 times 1. And because they're the same sign, it doesn't matter where you put them. So now we have our solution. X is equal to 10. This is called the zero factor principle or the zero factor property. And x is also equal to 1. And basically, the zero factor principle is just a fancy way of saying take the opposite of what you got inside the binomial, set equal to 0, and solve. That's it. You get 10 and 1. So we have to look and find out if 10 and 1 are possible solutions. So let's go ahead and erase the original right quick. Just the part where we started raising it to the second power. And we're going to go ahead and plug in those values to see if we get any funny business, like if we have a negative inside the square root or something. Okay, so let's go ahead and start by plugging in positive 10. So if you plug a 10 here, you're going to get 3 times 10, which is 30. That's going to give you a 36. The square root of 36 equals, this is 10 minus 4. So you get the square root of 36 is equal to 6. Is that true? Yes. 10 is going to work, definitely. Now let's do the same as that thing, but with the 1. Let me erase this. And if you don't get any funny business, if everything comes out positive, then it's okay. So we have the square root. 3 times 1 is 3. 3 plus 6 is 9. And this is equal to 1 minus 4. I can tell this is not going to be good anyway. All because 1 minus 4 is negative 3. Sorry, did I just put a square root of 9? Yeah, the square root of 9. Okay, the square root of 9 is not equal to negative 3. You should never have a radical. A radical would never be equal to a negative number. So it's 10 and 10 only. So that's our answer today. Excellent. Okay, very similar to the last question. We'll pick up the speed a little bit. We have the square root 2x plus 13 is equal to x plus 5. Start off by squaring both sides. So you get 2x plus 13. It just comes out equals, this is going to be x plus 5 times x plus 5. I'm going to show you a little technique that my old high school teacher, Mr. Simmons, taught me. Square the first term, square the last term, multiply the two together, and double it. You get 10x. You can test it. It's tried and true. Remember, you can always put your two binomials or you get the same result. Right, anyway, but minus 2x minus 2x minus 13 minus 13. You get 0 is equal to x squared plus 8x. And then 25 minus 13. That's a 2, and that's a 1. I can do better than that. All right, plus 12. So, let's see if we can factor it up. We have x and x. The signs are, the plus c means that the signs are both going to be the same. They're both going to be whatever this is. Or you can remember that all pluses is all pluses. Okay, so factors of 12 that will add to give you 8. So divide by 2, multiply by 2. Got it. 6 times 2. So go ahead and put your 6 and 2 there. So your possible solutions. I emphasize on possible because we have a square root. We have to test. X is possibly equal to negative 6 and possibly equal to negative 2. And as you know, we're going to have to test them. So we're going to put them into the original here before we square them. So remember not to include the squares here. Let me erase these little things. Okay, so we're just going to test them. Okay, so we have the square root of 2 times negative 6 plus 13 equals negative 6 plus 5. You know what? Let's save some time. On this right-hand side right here, negative 6 plus 5 is negative 1, and there's no way a radical can be negative. So we will not be using the, let's use a different color. We will not be using the negative 6. There's no way. All right, but what about negative 2? So I'm going to plug in up here. This is the square root of 2 times negative 2 plus 13 inside the square root equals negative 2 plus 5. Well, the right-hand side is okay because negative 2 plus 5 is 3. But over here on the left, we have negative 4 plus 13, which is square root of 9, which is okay. Is a square root of 9 equal to 3? Absolutely. So negative 2 is your only solution that you're going to use here. Let's go ahead and enter that in. Excellent. All right. Moving right along. All right, so we have x minus the square root of 2x minus 15. I'm sorry, 2x minus 5, and then equals 4. Let's go ahead and clear everything here. So we have x minus the square root 2x minus 5. I don't know why I said 15 equals 4. Okay, so for this guy, here's what you want to do. We have a radical, correct? We would like to square that radical, but we can't square it until the radical itself is by itself. There's a couple of ways we can go about this. We can move the x over and then divide by -1, or we can move the square root of 2x minus 5 over, which is still underneath the radical, and move the 4 over. Let's do that. So check me out. I'm going to add this 2x minus 5 underneath the radical to both sides. So that goes away. You're just left with x is equal to 4 plus the square root of 2x minus 5, right? And I still want the radical to be by itself. So I'm going to move this 4 to the left-hand side. You could have done this in one step. It's up to you. Now look, now we have the radical by itself. So now we are free to take the square root and everything. I'm going to put a star right next to here because when we're plugging in, you're going to see it's a lot easier to plug in stuff like this when it's, well, you know what? You can plug in wherever you like, to be honest, when we have our test values. Most people say, hey, plug it into the original, see if you get what you're hoping for. But anyway, let's go ahead and square both sides. This is, I don't want to use white. This is x minus 4, the whole thing squared, is equal to square root 2x minus 5, the whole thing squared. So this is just x minus 4 is equal to, oh, no, it's not. I'm pretending like it's a radical. This is x minus 4 times itself equals, this comes out 2x minus 5. Over here, we can use our little trick, or you can just use FOIL. Square the first term, square the last term, multiply the 2 and double it. Let's bring this stuff over to the left-hand side. You get x squared minus 10x. All I did was subtract the 2x from both sides. And then add the 5 to both sides, you get 21. So let's go ahead and factor it up. X and x. Look at your C term. Always look at your C term first. They're both the same. The signs are going to be the same because it's a plus. They're both going to be whatever that is in the middle. Factors of 21, that would give you 10, 7, and 3. So x is possibly equal to 3 and possibly equal to 7. I emphasize on possibly because we're dealing with radicals and we just can't take it for granted. So I'm going to plug it into right here to this part where I got everything like nice and situated. You can always plug into the original and everything should still come out correctly, but I'm going to plug it in here. So if I plug a 3 in there on the left-hand side, am I not going to get 3 minus 4 on the left? That'll be 6 minus 5, right? When you plug in the 3, you get 2 times 3. But look at the left. It's a negative. A radical can never equal a negative. So we're not going to use the 3. What about the 7? Let's erase that. Okay, so we have 7 minus 4 is equal to 14 minus 5. All I do is plug that 7 into the 2x portion. We get 7 minus 4 is 3 is equal to the square root of 9. Is that true? Yes, it is. So 7 is one of our answers. Is the only answer, actually. So our answer, the only answer that worked is 7. Good job. Okay, so for question 5, we have the square root of x plus 5 plus 1 is equal to x. All right, let's go ahead and write that down. We have x plus 5 plus 1 equals x. And it's the same as the previous problems. We want to get the radical square root of x plus 5 by itself. We have to move this 1 over, so let's go ahead and start by subtracting 1. So we have the square root of x plus 5 is equal to x minus 1. All right, so now we're going to go ahead and raise both sides to the second power. So on the left side, the x plus 5 just comes right out. The radical and the square, they cancel each other out. On the right-hand side, we have x minus 1 times x minus 1. So if you like, you can go ahead and FOIL. You can do the little shortcut trick. The shortcut trick says you square the first term, you square the last term, and you multiply the two together, and then you double it, so you get negative 2x. Okay, let's go ahead and bring that negative x. Let's subtract x from both sides. And while we're at it, let's go ahead and subtract 5 from both sides. So that's gone. Over here we get 0. So we have x squared minus 3x. And we're going to have minus 4. So, factor it up. Make your two parentheses, x and x. We have our c is negative, so the signs have to be different from one another. So plus, minus, minus, plus is up to you. Factors of 4 that when you subtract them will give you 3. That's 4 times 1, right? So we're going to use 4 times 1. That's the factor that we're going to use. Remember that the bigger number takes the sign. So the bigger number here is 4. So 4 is going to be the same sign as your b term. That's what I mean by the bigger number takes the sign. So look at our solutions. We have x is equal to negative 1. And then we have x is equal to 4. Remember, these are possible solutions. We're not quite sure yet until we plug them in. So let's plug them into the original. Let's get rid of this for 1 second. Okay, so we're going to plug right into here, right in the original. We're going to put negative 1 in there. Negative 1 plus 5. Right here, we're testing. Negative 1 plus 5 is going to give you a 4. Then we have plus 1, and this is equal to negative 1. And 5 is not equal to negative 1, so we're not going to use the 1 this time. What about the 4? So we have the square root of 4 plus 5, which is the square root of 9. We're adding 1, and we're going to see if this is equal to 4. Square root of 9 is 3. 3 plus 1 is equal to 4. So yes, 4 is our only answer this time. So let's go back, type in a 4, and call it a wrap. Well done. All right, next. All right, so number 6. Number 6 is not as scary as it looks, I promise. I know I make a lot of promises, but I'm serious. All right, let's go ahead and put the 7th root. This is made to scare you away. We have 4x minus 5 equals the 7th root of 8x plus 55. Okay, so to get rid of a radical, we raise the radical to the index of the radical. The index here is going to be 7, so you're going to raise it to the 7th. And that's it. So I'm going to write it again here so you can see what I mean. Seventh root of 8x plus 55. Okay, so we're taking the 7th root of both sides, so we can raise both sides to the 7th power. And that's going to cancel a lot of things out. So, yep, that goes away. And we're only left with what's inside of the radical. Look at that, really nice. We just have to bring some things over and we can call it a day. Let's go ahead and subtract 4x from both sides. So we get rid of that. And let's bring the 55 over to the left. So we're going to subtract 55. So we have negative 60 is equal to 8 minus 4 is 4x. Divide both sides by 4. And we get x is equal to negative 15. Now we want to make sure that negative 15 is a solution. So let's plug negative 15 into your original up here. So we have the 7th root. Let's close everything off. We have the 7th root of 4 times 15. I'm sorry, negative 15 minus 5 is equal to the 7th root of 8 times 15 plus 55. I can do better than that. So we can put it down here, the 7th root of 8 times negative 15 plus 55. You know, these numbers are a little bit messy, so what I'm going to do, I'm going to go ahead and plug these inside my little calculator here. Let me let you guys, all right, there we go. Okay, so we're trying to find the 7th root of 4 times negative 15. So let's do that first. 4 times negative 15. And then we're going to subtract 5 from it. We get negative square root of 65 for the first one. So we get, not the square root, the 7th root of 65 is equal to, and let's see if we get the square root of, I'm sorry, I keep saying square, the 7th root of negative 55 on the right-hand side. So we're going to take 8, we're going to multiply it by negative 15. And we're going to add 55 to that. And take a look. We do get negative 65. The 7th root of negative 65. Now, normally, whenever we have a square root, remember that we were saying that it's no solution and it's not possible to have a square root of negative 65. That's because the index, the root, was even. Whenever you have an even root, 2nd root, 4th root, 6th root, when the index is even, you cannot have a negative inside. But the index here is 7, is odd, so that is allowed. So we're good. The left side equals the right side. So the answer is negative 15. So let's go ahead and put that answer in. Negative 15. Okay, so you can see that even though we have negative answers inside the radical, they're still correct. Only if and only if the index is odd. All right, let's go ahead and knock this one out. Okay, we have the 5th root. Yeah, they're really trying to up the ante. All right, so we have the 5th root of 2x squared plus 7x minus 9 is equal to the 5th root of 2x squared plus 8x plus 6. So once again, we can go ahead and take the 5th power of both sides. So you know what? Since we already know that, since we're raising the left side to the 5th power. So here's what I'm talking about. We're raising this side to the 5th. We're raising this side to the 5th. So they all go away. Since we already know that, let's just go ahead and write what we have left. We have 2x squared plus 7x minus 9 is equal to 2x squared plus 8x plus 6. All right, so we're going to start bringing some things over. Let's subtract 2x squared from both sides. And you can see here, they go away completely. They cancel each other out. Now we have 7x, we have 8x. How about we bring, we'll bring the 8x over to the left by subtracting it. So that goes away. You're left with negative x. And while we're at it, let's go ahead and add the 9 to cancel out the 9 from the left. So that goes away. 6 plus 9 is 15. So we have negative x is equal to 15, but we didn't come all this way for a negative x. We came here for positive x. So divide both sides by -1 or multiply both sides by -1. You get the same result. Just whenever you end up with a negative x, just change all the signs in your equation. So this becomes positive and that becomes negative. So we got negative 15 again. It's interesting. So negative 15 and good job. Okay, so next, same deal. Yeah, you're gonna want a lot of these on your exam or your quiz or whatever you're doing. All right, so we have the 4th root of x plus 15 is equal to the 4th root of 4x minus 3. Okay, so let's go ahead and take the 4th power of both sides. So we have x plus 15 is equal to 4x minus 3. Let's go ahead and subtract the x from both sides. And let's add the 3 to the other side to get rid of it. So we have 18 is equal to 3x. So x is equal to 6. Now remember, these are even powers, so you want to go ahead and you always want to check. I noticed in the last example I didn't check, but you always want to check, okay? So let's go ahead and plot the 6 into this equation over here. We have the 4th root of 6 plus 15 is equal to the 4th root of 4 times 6 minus 3. And we want to see if both sides are equal. So over here we get 6 plus 5, which is 21. So we have the 4th root of 21 is equal to, we have 4 times 6, which is 24. 24 minus 3 is also 21. We got it. So this right here, this x minus 6 is definitely our answer. 6. Got it. Fantastic. Okay, number 9. Now the interesting stuff. Not that radicals are not interesting, but you know what I mean. Okay, we have the absolute value of x is equal to 15. So with the absolute value stuff, when you're doing absolute value, you want to keep in mind that you have 2 possibilities. Like, for example, what is the absolute value of -3 and what is the absolute value of +3? Well, the absolute value tells you the amount of space that that particular number is from 0, that particular integer is from 0. So how many spaces is -3 away from 0? If you take a number line and you put 0 in the middle, and you have 1, 2, 3 right here, you have 1, 2, 3 right here, -3. How many spaces is -3 away from 0? Well, we can count. We start from here. We say 1, 2, 3 spaces. So the absolute value of -3 is 3. What's the absolute value of +3? Once again, in other words, how many spaces is 3? What is the distance how much distance is 3 away from 0? So let's backtrack. 1, 2, 3. So the absolute value of +3 is also 3. So you can see we got 2 of the same answers. We have 2 3s here. They're both coming from 2 different possibilities. So that's the idea you want to have with absolute value. You're going to have a negative version. You're going to have a positive version. And you're going to see they're going to keep on giving us problems expressing that. So the absolute value of x is equal to 15. So all you do, you're basically going to branch those off. What you do is you let it out of the absolute value. So x is equal to +15. We have the positive version. And we have x is equal to -15, the negative version. That's it. That's it. You take the negative version of whatever this guy is right here, put it on the right, and you take the positive version and you put it on the left. And you're going to see they're going to give us binomials. They're going to have us solving. It seems like it's really, really simple. And the concept is simple as long as you remember that you need a positive version and a negative version. So let's go ahead and put 15 and -15. You're gonna see. Yeah, look at this. Now it's starting to get slightly more difficult, but not too much. And I'll show you what to do. So we have the absolute value of x minus 8 is equal to 4. Okay, this absolute value is by itself. There's nothing sitting outside or anything like that. So looks like we're ready to just jump in. So let's make a little cutoff like right here, so that we're going to have the negative version and we're going to have the positive version. So go ahead and take it out of the absolute value. This is going to be the positive version, so 4 is going to be positive. On the right side, we're going to have the negative version, so we have x minus 8 is equal to negative 4. So just like the last example with the 15s, you want to take whatever the right side is and just put a negative in front for the right hand side. And on the left side, you're going to leave it alone. Just keep it positive. Okay, so let's solve this. X is 12, and let's go ahead and solve this. That goes away. X is negative 4 plus 8, which is 8 minus 4, which is 4. So there go your two solutions. And you want to make sure that these are right. So we have 12 minus 8. Go ahead and plug this back into your original. What's 12 minus 8? 12 minus 8 is 4. Absolute value of 4. Is the absolute value of 4 equal to 4? Yes, it is. So definitely 12 is one of your answers. And over here, let's go ahead and plug the 4 into your original. We have 4 minus 8 is equal to 4. We get negative 4. The absolute value of negative 4 is equal to 4. Is that true? Yes, it is. The absolute value of 4 is, the absolute value of negative 4 is positive 4. So we have two solutions. We have 12 and we have 4. Okay, so number 11, let's go ahead and write it down. We have 5, absolute value of 2x minus 7 is equal to 15. Let's go ahead and get rid of this 5 that's sitting outside. You want to make sure that the absolute value is by itself before you start making the negative version and the positive version, before you branch off. So let's get rid of this 5 by dividing, because this is 5 times the absolute value of 2x minus 7. So to get rid of multiplication, you use division. So we have 2x minus 7 is equal to 3. Okay, and now we're free to branch off on both sides. So let's go ahead and make a little cutoff right here. We have the positive version, so go ahead and take it out of the absolute value. So we have 2x minus 7 is equal to the positive version of the right, which is 3. And over here we have 2x minus 7 is equal to the negative version of the right hand side, which is negative 3. And that's it. Just go ahead and solve, handle business. We have 2x is equal to 10. Divide both sides by 2. We're going to get x is equal to 5. Over here, same thing. At 7, you get 2x is equal to 7 minus 3 is 4. So x is equal to 2. And that's it. 5 and 2 are your answers. So let's go ahead and put 5, comma 2. And that's it. Good job. All right, number 12. So we have 3 times the absolute value of 3x plus 2 is equal to 17. Okay, there are a few things here. So we really want to get this guy here by itself. But there's a lot of other things in this way. We have the 2 sitting here, and we also have the 3 sitting here on the outside. I want you to always get rid of the thing that's furthest away from what you're looking for to solve. Like we have x right here. We have a 3 times this. This is pretty. This is like very close. This 2 is sitting by itself. So let's go ahead and move that over to the right. So that goes away. You're left with the 3 multiplying with the absolute value of 3x is equal to 17 minus 2 is 15. And now we have to get rid of the 3 by dividing it, like in the last problem. So we have the absolute value of 3x is equal to 5. Now we have the absolute value of 3x by itself. So now we're free to branch off. into the positive version and the negative version, we have 3x. Go ahead and take it out of the absolute value bars. 3x is equal to the positive version of your right. And over here, we have 3x is equal to the negative version of your right. So go ahead and divide both sides by 3. You get x is equal to 5/3. And over here, we get x is equal to negative 5/3. And that's it. Excellent. Okay. We have the absolute value of x plus 3 plus 9 is equal to 8. All right, same routine. We got to get this absolute value by itself by getting rid of this positive 9. We're getting rid of the positive 9. So this is x plus 3 is equal to negative 1. Now let's freeze right here. Do you remember the example I told you of the positive 3 and the negative 3? The absolute value of positive 3, this is just an example here. The absolute value of positive 3 is 3. The absolute value of negative 3 is also a positive 3. So no matter what's inside of the absolute value, like for what we have here, the x plus 3, the answer will always come out as a positive. So if you ever get a negative answer, if you ever have an equation that says the absolute value of something is giving you a negative, that's no solution. So you're going to want to see a lot of those. As soon as you get the absolute value by itself and it's equal to a negative, that's no solution. The sooner you identify that, the better, so you can move on to more problems. All right, this is the last problem. This is question 14. Let's go ahead and do the grand finale here. Plus 7 is equal to 7. Very interesting. All right, let's start by getting the absolute value by itself by subtracting that 7 from both sides. So we have 5x minus 1 is equal to 0. So let me humor you right quick. We have the absolute value by itself. So we're free to go ahead and take it out of the absolute value bars. And we need a positive version and a negative version. So we have 5x minus 1 is equal to positive 0. And we have 5x minus 1 is equal to negative 0. Now, there is no such thing as a positive 0 or a negative 0. 0 is 0 no matter what. If you put a negative in front, it's still going to be 0 at the end of the day. So you know what? These two are the same exact equation, right? So you're only going to have one solution this time. There is no positive or negative version. So you know what? We'll just solve for one of them and we'll have our answer. So x is equal to 1/5 over here, and you know x is equal to 1/5 over here as well. So in this case, the answers are the same. So you, listen, only put it one time, okay? You don't want to put multiple. You don't want to put the same solution twice. All right, and that is it. Did we get our 100? Yes, we got our 100. That is it for 1.6.